Hello guys. So today I'm really talking in English today. A moment please. I need to a new mode. Yeah. Stream. So today I'm just talking English to practice my English and also to practice the programming. And for that I decided to start a project. I already have this project really in a far phase of development, but I really want to do it again. Let me delete these two. Forgot to delete. Okay, nice. I really to start it again in video, just to practice the English and the programming as well. All right. So what I want to do now? The project itself is simple. It's basically backend to manage points, work point. I don't know how to call this in English, but is that kind of point registrations that is related to the basically the time that you arrives in your job and the time that you leave your job. Okay, then I want to create this backend to perform that, to store that kind of data, and for that I want to use the Kotlin ecosystem, and we will use a lot of Kotlin tools. For example, the Ktor web server. We it's hard to say that, bro, but we should use exposed. I keep a file here. This file is very simple. I keep it here because I don't want to write this from scratch, but the other things is from scratch as well. And to start this, I really want to just code the entire project, for example, in a single file, and after that I want to clean up it to the clean architecture or some kind of architecture like that. Okay, let me open the YouTube to see if the live streaming is fine. I didn't check it. Let me see what we have. Okay, nice. So how can we start this project? The first thing is that we have to know is that we're going to use Ktor. Ktor is basically is a web server such as Spring Boot, but Ktor is more declarative and more modern in terms of syntax and design, and we should use it. How can we start it? Just by doing I also need to delete this, I forgot. Okay, let me do embedded server. Here we call netty, and here we set the port, for example this, and here we call start, passing through to wait connections. Okay, here we can just call the routing block, and here we can just create our road routing. I can create, for example, hello get route, and we can respond for the client that made this request, something like respond text hello from authenticator. Nice. Now if I run this and open and try to access the port 8080, I should to see this text, but I will not open this in the browser. Let me to start creating tests. We should to test it in the right way. Route tests. Okay, the tests are very cool because we can do, for example, fun test hello root. In Kotlin we can use this kind of syntax that we can write a lot of default text for name of the things, functions for example, and we just need to put in this accent here. Now let me mark this as a Kotlin test, and to test the route we set this equals to test application. Test application is a dependency. It comes from dependency that I put here in somewhere. Test host, I think this is all right. And now we can create a client, a mock client and fake client that can perform requests for our server. Okay, to do that we can just store it in a variable seed of client, create client. This offers scope to configure the client. We can configure it a lot of things. For example, we can install content negotiation, but this content negotiation is wrong. Let me take this to a function. How is it exactly? Hey, Thiago! Não, cara, não é específico para Android, não. Dá pra gente fazer programação geral com Kotlin, nem se preocupa com isso, cara. Android é apenas uma das coisas que a gente faz com Kotlin. Kotlin é uma linguagem bem completa. Tanto é que eu tô brincando aqui nesse projetinho aqui, fazendo uma API de backend, né? Então, basicamente, a gente consegue programar tranquilo aí. Alright, back into the English. We need to practice English, bro. Okay. I need to remember how to instantiate client. Whoa. That's really right. Client. Okay, we have two kind of content negotiation. That's right. Create client. Here we have scope. Well, oh, that's crazy. Let me take all these things in a function, separate function. Let me extend this context. Nice. To do, and we have returned this. Nice. Okay, all right, this is the way we can, for example, use a fake client. Now we can instantiate it here. It's equals to setup client like this. This is an extension to the application test builder that's here, and basically we can now make requests to our API, to our server. But to happen this, we need to abstract something. For example, this code is starting the embedded server right in the main function. We can, for example, take this configuration, that is the routing configuration, and put it in a separate function right here. And we can do that by the same way, extending the application context and create something like setup routing configuration like this, and taking this block of code, putting in here, and we can call this function here now. All right, routing configuration. Why we can do this? This is possible because we extended the application type, the application scope, that is the same context that is inside of this function, and we can do that because we extended this and we have access to this function inside this. Now this function is accessible in other places. Here, for example, we can call the same function here, and then we can call just routing configuration. Okay, now in the unit tests, in the automated tests, we just set up the server, and we now have access to the client that can make requests for it. How can we do that? Now we can just perform c.get or any other method, HTTP method, for example, post, or even patch or delete. We are using this client, but I want to do a get, and this is the way I can define the endpoint that I want to make the request. That is from this endpoint. Hello. Now we can store the result of the request here. Response is equals to that. I can, for example, print line response dot body as text. Now I can see the text that was the text form of the response. Let me run this test. Oh my god, I clicked the debug. Yeah, just finished. I clicked in the debug. I want just run. Okay, let me click run. Okay, strange, but okay. Here is the debug string. This came from our root. That's crazy. That's really crazy. Okay, this is basically a test. I can make an assertion here. Assert equals response expected equals to HTTP client HTTP status code dot okay, and the received, the actual is response dot status. Then we can test it using the status, and it's fine. This method sends the text, and by default it sends a status code. Okay, now we need to do more things. We have other routes in our project. We want to make users able to create time registrations of their entry and leave times of their jobs, and for that we need to store users in our system. Is one of the first things. In this first moment, we can treat all the data just as a list in memory only. For example, we have users that can be a mutable list of, but we don't have any kind of definition of what a user is. How can we define a user? Their class user. User will be basically something that has an ID, name, string, email, maybe a mail, hash, the password, remembering that we don't store the password itself, we store only the hash of this password. Okay, and we can also deal with roles, but I will not to deal with roles now. No, let's do it. Role can be an enum class. Enum class role. The full no standard. Let me call standard. And here we have admin. Two kind of roles. User role. Let me call this user role. Select all. Okay, nice. Now we have basic representation of what a user is. Then I can have now a list of users, mutable list of user. Nice. This is just a list source of data just in the memory. What more I have to do now is we need to have two kind of routes. I need a register or sign up, and login route. Both routes are designed to be accessible by the users. All right. The first thing that I have to do now is the sign up. Sign up is a route that we use to create a user entry, and this is a route that we use to check if a user exists and return a token, a silent token, secret token to the client, to the user, and it will be able to use this token to access authenticated routes. But here we need to create the user. At this point, we are not caring about the architecture. We are not taking care about the architecture. We can basically call the data operations really inside the block, this scope. Okay, but let's create something called, can be an object, users handler. All right, let's create something like that. Memory users handler. Now let's place the data inside the object, and here we will create the functions that manipulates this. The first function is create user. To create a user, we need the kind of information of that user to create it. And how can we have that kind of information of data? We need to deal with requests. Let me create a function called that is also an extension to the application type. This function we will call serialization configuration. This, let me install content negotiation plugin, the same way I configure it here. Same way, I like to put this property to false. It's important to make the parsing not linear. Now I call the serialization configuration here, and I need to call it here as well in the test to make the test okay and fine. Now, having this in hand, we are able to receive requests. We need to receive a request of a user, a creation of a user, and use that kind of information that came from the client, for example, and parse it to the user and insert it in our data. For this, let's create another data class called user create user request DTO. This is just a basic type of DTO, and this will be received from the incoming requests. Serializable, we mark it as serializable because this will make possible to convert it from JSON string to object, and of object to JSON string. In here we need to know that we are receiving the password, real password here, okay, because this is request to create the user itself, and to create it we need the original password in the first moment, and after we receive it after the first moment we will just hash it, and after we hash it we store the hash instead of the original, instead of the plain. Okay. Here in the route that is called sign up, let's to receive a request called rec call dot receive create user request DTO, and after that we need to we can perform some validations of this type right in the initialization block. For example, we can see if name dot is empty. We can throw an exception, an error. I will create the errors after, but this is the way. Okay. After receiving the request, and if the request was properly deserialized, I can call my function. This function can also use the kind of type this rec request DTO create user request DTO. Then we can just make users plus equals user, that is the type of user of data. This is a piece of data that is being stored in our application. This, in other hand, is a piece of data that's the service only to transfer data from client to our server. Here we need to create an ID. ID can be created very simple. We can use an incremental ID, users dot size plus 1, simple ID, just to dummy ID and fake ID or something like that. ID equals to next ID, name equals to DTO dot name, and mail equals to DTO dot mmail, and one more, and hashed password equals to DTO dot password, and keep calm. I back this in a moment. And oh, in the role, I forgot the role. Oh, that's fine. And user role equals to DTO user role. Okay. See, we just created enough data. We just inserted the data in our root, in our source of data, that is this, and we did it by asking for a DTO, and we have a DTO here. Now we can just call memory users handler dot create user, and we pass the DTO here. Okay, we can also return the next ID as well, just to send the ID back to the client after the operation finish. For example, we can do call dot respond http status code dot okay, and we send the result. In this code, we are ignoring a lot of things. The first thing that is an oral really terror is this. We are storing the plain password in a hashed password field. We need to hash the password. Let's create an object called dummy password hasher. It's an object, a helper object to hash the passwords. We will have two kind of functions. The first one is hashed. Is a function that takes plain and turns the plain into a hashed version. How can we do that? In a dummy way. We can create a dummy suffix let's create a dummy suffix like this, and we will do basically plain concatenated with the dummy suffix. And let me explicitly the string type. And we need another function called plain matches hashed. We will also ask for the plain and also the hashed. This method returns boolean. We can just perform return hashed dot replace dummy suffix by nothing, and we compare. If we remove the dummy suffix from the hashed string and this string is equals to the plain, then plain matches the hashed. Do the reverse way. If the plain match is equals to the hashed version of the string without the dummy suffix, there is something kind of fixed, then both strings matches. This is a dummy way. In the real context, we use real library that makes this kind of hashing. Okay, but the reason that I did this is just to perform this. Let me take this and dummy password hasher hashed pass this. Nice. Okay, now I have a function that inserts a new user in our system. We can also make another thing that is something like this. If, for example, email should be unique for us, we want to have only unique emails in our database. How can we do that in this dummy memory handler? We can just make a filter. If users.any it.email equals to dto.email. Let me do the reverse way like this. If the data read contains something like that, we can throw drawable. Something like that. Okay, and we now can remove this and return normally. Did you see that? We just fail fast the mechanics, the architecture. The function will fail in the first moment, and if everything is okay, everything will be okay. Now we need to involve this in a try cat, for example, catch the possible exception or error like this, and if everything is okay, we return out as always. Else, if we catch something, we just respond HTTP status code unprocessable entity maybe, and that's okay. Can also return this. This kind of syntax is very nice. This is one way, but we can simplify this by using a status pages plugin. Let me create another configuration extension function. Application.status pages configuration. Let's install it. Status pages. Exception. Let me remember how is the syntax of this. Throwable. It's like this. When we catch an exception in the flow of our server in the flow of our server execution, we can catch it globally using the status pages configuration. Did you hear that? That's insane. Then we can just call that respond HTTP status code internal server error or something like that. Some period. That's really generic. We can improve this, but at this moment we don't need to think like that. Status pages configuration, and here as well. How can we test? How can we test this? We create a sign up route, and we can, for example, create a test function for it. Fun test test what limit create equals test application test mark test val c well setup client. Nice, we already have a client function, and let's perform c dot post. We need to do it to the sign up route endpoint. We also need to specify something here, that is the header. No. content type, I remember it. Application JSON, and the body of the request, let's set it here by defining set body. We need to define it here, and we'll be just create user request detail, and the name can be my own name, Lucas. Name, the email can be asdf@abc.com. Password plain, the plain password will be okay, this, and the role, user role admin, can be admin. Now we let me store this in a variable sign up response, and we can analyze this variable here. Cert equals expected HTTP status code. In the successful case, we need to return create. The created, expected is created, and the actual is create sign up response.status. Okay, let me run this function and see the result. Okay, the function passed in the test, but what if I make two requests in following? Let's imagine that I made this before, okay, and after that I'm trying to do it again. Let me see what the test says for us. All right, it failed. Perfect, failed as we imagined it, and returned 500 internal server error that was handled by the status pages plugin here. And those kind of exceptions we can basically, how can I say, we can basically abstract them to custom types. Yeah, custom error types. For example, we can create some kind of class database error that is extended from throwable, like this, database error, and I can throw this in the handler instead of a generic throwable like this. Nice. But now I need to catch database error instead. Calls dot print stack trace, but I think that this will not work because we need to find the root cause. Well, oh, Internal API, strange. Okay, let me see what happens. Okay, nice. Error in database operation is the custom error that we created in the top of the code, top of the file. Crazy. And it is the root cause. If we didn't use the root cause, what are we receiving here? Same thing, because it is the root cause in any way. Alright guys, this is the practice for today. I'm using this kind of project in programming just to practice in my English. My English is very bad at this moment. Unfortunately, I don't have some kind of opportunities to talk in English. I'm just talking alone and with you, but it's nice to practice my tongue in this such a language. And that's it. If you want to see more things related to the Ktor development or to the backend development using Kotlin with Ktor or exposed in tools like that, just comment, leave a comment, and subscribe and so on. This live will be recorded, will be stored on my channel, and we can watch it in any time. And that's it. Thank you, and thank you guys. Have a nice night. Have a nice post midnight for you all.